All right, folks, we got a good one over here, a good integral, and it's a bit feisty. So before I do it, I want you to try as first. So go ahead and pause the video and give it a try. All right. So three, two, one, and let's try to solve it. Okay, so before we go on and brute force these things, let's see if we can make it easy to solve. So do we see something here? Can we manipulate these integrals in some way that will give us some peace of mind, I guess, give us some sanity? Yes, we do. We can see that this denominator is familiar. Why? Because we know the trigonometric identity 1 plus tangent square of x equals secant square of x. This is a very, very common trigonometric identity, and we can use this, substitute this part for secant of x here. So that will make things much, much easy. So let us do that. Integral sine 1 minus tangent square of x divided by secant square of x dx. Very nice. So we can also do one thing. We can just make this into two separate fractions. So this one and this one. So let us do that because we have this minus sign over here, and it's again going to make things much easy because whenever we can divide it into two different fractions separated by a addition or subtraction, then it's definitely much, much easy. So okay, all right, minus tangent square of x secant square of x dx. All right. Now this is simply just cosine square of x, and we can do some manipulation here to find out. But let us write this part, this thing, as we're gonna separate this again. So cosine square of x dx minus the integral sign, and let us solve for this. I mean, like simplify this. So what is tangent square of x? That is simply, let me write it in a different color, sine square of x divided by cosine square of x. And secant square of x is nothing but cosine square of x. And we can immediately see that these cosines are going to get cancelled. So we'll be left with nothing but cosine square of x dx on this side minus sine square of x dx on that side. So immediately we can see that it has become much easy. But if we try to solve these integrals using our typical ways of solving, that is u substitution or maybe by parts, I don't know, we'll face a problem because if you substitute, let us try this just doing a u sub, all right? So let us define u as cosine of x. Cool. So we can just go ahead and make this an u square dx, but we gotta find du, right? We gotta find du. So du, I mean, we gotta substitute for dx, that is. So let's find substitute the dx equals du divided by the derivative, first derivative of cosine of x. Again, I'm doing this in my head, so quick stuff. So this is minus sine of x. So this is going to be minus sine of x here. But there is no sine of x, so we cannot simplify this. This is still in terms of x, so it's going to make things a lot, So we're gonna do something else. What do we know about these squares of cosine of or sine? We know that they relate to the half angle formula. That is, for cosine of x, the cosine of 2x equals 2 cosine squared x minus 1. And for sine of 2x, sorry, again for cosine of 2x, this is also equals to 1 minus sine, actually 2 sine square x. We know these, and so we're gonna solve, I mean, use this half angle thingy to solve for that one. How? Let us do some more simplification, do some more algebraic manipulations. So for this equation 1, and we're going to do this equation 2. Okay, so for 1, let us bring this 1 over here, I mean transpose it, and divide the whole equation by 2. So that will give us cosine square x equal to, we can just do this, and 1 1 plus cosine of 2x. So this will be the answer for, I mean, simplification for cosine square x. And for sine square x, we can just do the same, bring this one over here, and or we can just bring this one over there and this one over there. So it's going to be, again, there will be a half, and 1 minus cosine of 2x. All right, so we have this one, and we can use this in our these integrals to make things easier. Let us try and do that. Again, I encourage you to try your own, I mean, simplifications and stuff, definitely. So, because I'm again doing it very fast and quick. So I may have skipped a lot of steps, but again, try them out on yourself, right? So we can substitute that 1/2 1 plus cosine 2x and dx minus, we got a half again here, and is it correct, minus? Do you have minus? Yes, correct. All right. So plus, no, not plus, it's a minus for sine dx. All right, great. So we can factor this halves out because integral rules, right? So we can do that, and let me write that with a different color. Half, and we got 1 plus cosine of 2x dx, and we got a minus over here again, so minus half times, not times, integral of the same thing, except we got a subtraction here this time. So we can just, we know this, we can integrate 1 with respect to x, but we can also do this. We will just take a simple u sub. U will be 2x, so dx will be du by 2, and this 2 will get factored out. So again, we'll have something like this. Let me keep the 1/2 over here, something like that. And let's integrate this into here. So we got 1 dx, that is simply x, plus, as I said, half, because of the u sub, we got this thing over here. Again, sorry about that. We gotta integrate this. So that would be sine of 2 of x. All right. And we can close this bracket, right? We can close this bracket. Okay, great. So again, we have a negative half over here. Again, we got x, and again, we got a half, and we gotta integrate this part. Again, like it will be like this. So again, we got a sine of 2x, and we can close this again. Whew, okay, a lot of work. So we can also simplify this further. Again, we need to use a plus c over here. Again, we could have done that on the last step, but simplifying even more, 1/2 x plus 1/4 of sine of x, sine of 2x actually, minus 1/2 x plus, we got this 2, so they will add up, 1/4 of this thing, and we got a plus c, and immediately these will get cancelled. So in the end, we'll be left with, let me take the other page, next page, 2 times 4th sine of 2x plus c. That is simply saying half sine of 2x plus c. All right. Let me see if this is correct or not. I may have made a few mistakes on the way. It is possible, entirely possible. So, am I sure of this step? Yes, definitely. Let me take the blue pen instead. Oh, no, the brown pen, yes. So, am I sure of this step? Absolutely. Absolutely, we can do that. Math gods said so. So, we can separate this. Absolutely correct. Why not? And can we simplify this even further? Absolutely, we can cut these things off, cancel these things, and we'll have this one. Can we separate them? Yes, because I mean, yeah, this is correct. Absolutely. Can we do this substitution? Can we? Is it right? Is it correct? Yeah, we know this. We know these, right? So we can solve for that. Half, it goes on over here, so it will cancel. All right, all right. Yeah, yeah, correct, correct. I'm sure of this one as well. And we can factor out the halves over here. Definitely, we are left with these parts. We can integrate this. But am I sure of this one? Let me check again. All right, let me check. Let me try doing cosine of 2x by itself using u sub properly this time. So this will give me dx u du by 2. All right, so we'll have 1 over 2 cosine of u and du here. And what is the integral of cosine? We know that the derivative of sine, right? We know that derivative of sine is cosine. So if we integrate both parts with respect to x, that will give me, because of the fundamental theorem of calculus, we got a sine. So we got half sine u, and also u is 2x. So am I sure of this one? Absolutely, I am sure of this one. This one is correct, and so is this one. So we can ultimately go ahead and say that absolutely this is the correct answer. Wow. So again, lots of things, lots of nuances, and this one was a really, really good integral. I loved solving this one. So I hope that you like this as well. So without further ado, I mean, not further ado, I guess. Yeah, just take care of yourself and solve more integrals. Yes, very nice.